Hi, welcome back, maths lovers and everyone alike. We're here live on Twitch and we're about to record the Intermediate Maths Challenge from 2022. It was sat last week, so at the recording this video, it was sat about 5 days ago. So I've got myself a copy of the paper, but I haven't got a copy of the answers. So I'm going to be going through this and doing my best guess. At the end, I'm going to mark it, and the way I'm going to mark it is I'm going to compare my answers to another maths teacher's answers, and if we both agree, we're going to assume we're right. If we don't agree, I will tell you guys what we both put, and we can decide maybe who might be right in this particular case. But we're going to give it a go, and if you haven't done one of these before, these are quite difficult. These are aimed at students who are about 14 to 16 in the UK school system, and they get 60 minutes of multiple choice questions. And they're pretty fiendishly difficult maths questions for the age that they're set at. There's no way realistically that you'll be expected to get full marks. So don't worry if you're doing this and you can only answer half the questions. Some people don't even understand half the questions. So you'll be absolutely fine if you give this a go and you're using this for practice. But the way it works is that you're going to get some marks. So you're going to get, down there, it says 5 marks for every question you get right from 1 to 15. There were no penalties for guessing wrong. So they're multiple choice. So if you are doing this in the real thing, make sure at the very end you at least go through and guess the ones you've not answered for the first 15. After that, you get 6 marks for questions 16 to 25. So you get an extra mark if you get it right, but you start to lose marks if you get it wrong. You lose a mark if you get any question from 16 to 20 wrong, potentially starting to get to the point where it's not worth guessing, and 21 to 25 is definitely not worth guessing unless you've maybe narrowed it down to 2 answers. So I'm going to go through. I used to be a maths teacher, but I haven't done that for a few years now, so I'm potentially a bit rustier than I used to be, but we're going to give this a go. We're going to jump in, we're going to look at the time. We've got 60 minutes to do the best we can, and we're just going to jump in. There's no calculator, and off we go. So, question number 1, how many hours is 6 minutes? Well, an hour is 60 minutes, and 6 out of 60 is the same as 1 out of 10. It's going to be B. The first question is always numeracy, and it's often quite a nice starter, but here we go. A lot of words here. My recipe for apple crumble uses 100 grams of flour, 50 grams of butter, 50 grams of sugar to make the crumble topping. When my family come for a meal, I have to use 2.5 times each amount to provide enough crumble. In total, how much crumble topping do I then make? Okay. 2.5 times each amount, so the total amount is 200 grams, and if we times that by 2.5, we get 500 grams, which is half a kilogram. Right. In the Caribbean, loggerhead turtles lay 3 million eggs in 20,000 nests. On average, how many eggs are in each nest? So we are going to be just doing some dividing here. We've got 3 million, which is 6 zeros, and divide that by 20,000 nests. And if we're dividing it, we can cancel out some of these zeros, divide top and bottom by 10 basically, and it's going to be 300 divided by 2, which is going to be 150. Workers digging a tunnel for an underground railway complete 5 metres of tunnel on a typical day. Working every day, how long will it take them to dig a tunnel of length 2 kilometres? They do 5 metres of tunnel on a typical day, so in 2 kilometres, how many 5 metres are there? 2 kilometres is 2,000 metres, so if we do 2,000 divided by 5, we get 400. 4 5s make 20, so 400 5s make 2,000. So in how long will it take to dig a tunnel of length 2 kilometres? 400 is over 1 year, it's 400 days, because it's on a typical day we're doing. So 400 is over a year, and it's going to be just over a year. It's going to be 35 days or 34 days over a year, depending on how many days in that particular year. Which of the following has the same value as 10,006 minus 8,008? I think just looking at it, it would happen to be the first one I glanced at. I think it's just going to be C, and the reason is that this is 6 less than this, and this is 6 less than this. And if you subtracting 2 numbers and you take 6 off both of them, they both become 6 smaller, but the difference remains the same. So it's just going to be this. I'm not even going to look at the other answers. But yeah, you can see they're just trying to trick you in lots of different ways there. Question number 6. We're flying here. It's a lot of numeracy so far though. What is 20% of 3 3/4? Well, of, when you're dealing with percentages, decimals and fractions, is another way of saying multiply. So 20% or 1/5 multiplied by 3/4. 3/4 is 15. 3 3/4 is 15 quarters. So if we just multiply these two, we get 15 out of 20 or 3/4. Yeah, that makes sense. There are 4 quarters in 3. Sorry, there are 4 lots of 3/4 in 3, and another 3/4 makes 5, and 20% is 1/5 of something, so that kind of makes sense. That is not a ridiculous answer, even though it looks like it might be a trick one. A function machine does the 4 operations shown in order. It divides by 3, then subtracts 10, then divides by 3, then subtracts 10. Iris puts a positive integer, inputs a positive integer, and the output is also a positive integer. What is the smallest possible number which Iris could have put? Well, to get the smallest number here, you would need to get the smallest output here. So what we're going to do is assume that the output is 1, and we're going to invert it and see what we start with. So 1 take 10, 1 take 10, so it's 11, so we've added 10 on. Times by 3 is 33, add 10 is 34, times by 3, 34 threes is 102, and that is one of our options. Because it's a positive integer, 1 is the smallest positive integer we can end with to get our smallest positive starter of 102. What is the difference between 40% of 50? What is the difference between 40% of 50% of 60 and 50% of 60% of 70? So we're just going to work these out. 40% of 50% is 20% of 60. And 20% of 60 is 12, and 50% of 60% of 70 is the same as saying 30% of 70. We've just done 50% of 60% separately, and 30% of 70 is 21, and the difference between these two is 9, which is one of our options. So usually I don't look at the options unless the question indicates which one of these is right or which one of these is wrong. And I work out what I think the answer should be, and then see if it's there. If it's not there, I've clearly made an error, and it might make me go re-evaluate what I've done. What I generally don't do is work it out and get an answer and go, oh, this one's closest. A number x is greater than 2022. Which is the smallest of the following? Well, this is going to be greater than 1. This is going to be, it could be potentially 1 or greater, because if x is 2023, that is greater than or equal to 1. This one is greater than 1. This one is definitely less than 1. And this one is definitely less than 1. So it's one of the last two. And if you're looking at which of the smallest is, well, if x is a positive number, i.e. it's bigger than 2022, x plus 1 is going to be a larger denominator than d, so it's going to be e. "100 rectangles are arranged edge to edge in the continuation of the pattern shown." So you've got 50 lying down and 50 standing up. Each rectangle measures 3 by 1 centimetre. What is the perimeter in centimetres of the completed shape? You're going to have this bit 49 times, because you've got, no you're not, you're going to have it 99 times. And that bit is going to take 1, because that bit is 1 high, because it's the width of the rectangle. That is 1 high, and that's going to take 1 centimetre off each of the perimeters in the shape. So you're going to get this times 99, because the end ones only touch once, so everything else touches twice. If you think about it, there's 100 shapes, and every one has one of these to its right, apart from the last one. So there's going to be 99 intersections, and each one of these intersections will take 1 centimetre of each shape, i.e. 2 centimetres total. So if we imagine splitting all out, so there was no touches, the whole perimeter will be all the perimeter of all shapes together, and then we're going to take on 99 times 2, because that's going to be 1 centimetre from each shape. So we're going to work out the perimeter of 1 is going to be 3 plus 1 plus 3 plus 1 is 8. The perimeter of all would be 800. And then we're going to subtract 2 lots of 99. That's 1 centimetre twice for all 99 shapes. So 2 99s is 198. So it's going to be 800 minus 198, which is 602, which is that option there. So it's an option we've got, that's good. There would be another way of doing that where you ignore this middle bit and you just count the tops and bottoms and edges and stuff and then add on the end bits which weren't blocked. But the end bits that weren't blocked is that way you get the extra 2. I imagine you're going to get 600 because the perimeter of each shape, the perimeter of that one is 6, the perimeter of that one is 6, that isn't kind of blocked. So you're going to get 100 6s plus a little bit at the end. You're going to get that little one at the end, and the same that little one at the end of the 100th one. So you're going to get 600 plus 1 at the end. So that's another way of doing it. It's just not the way I saw first. Right, we're making good time. We're 10 minutes in and we're on question 12, so we're in good stead here. The shape shown is made up of 3 similar right-angled triangles. So similar just means they're enlargements of each other. So whatever this side is the same as this side, and whatever this side is the same as this side. What is the area of the shape? So I think we've immediately jumped into a much tougher one here. So we're just, by using Pythagoras, that's going to be root 8, and then that's going to be root 8, and then by using Pythagoras again, that's going to be root 16, and that's going to be root 16. Hi Rassam. And so what we're going to do is work out the area of each shape separately. So the area of the small. So Rassam, so I'm doing this live on Twitch, YouTube. We've got someone in chat now. Hi Rassam. This is the Intermediate Maths Challenge. It is 14 to 16-year-olds in the UK, and it was sat last week. So this is the newest one I've got access to. So I'm working through it. I don't have the answers, and at the very end I'm going to check my answers with what another math teacher got, and just assume if we're both right, then we've got the right answer. So we're just working them out. We're now on to the slightly tricky ones. We've done about 10 or 11 easy ones. And we're just going to work out the area of the small one. So the area of the small one is a half of 2 times 2, which is 2. The medium one is a half of root 8 times root 8, which is 4. You can see a pattern here. And the large is half of root 16 times root 16, which is 8. It is nice that that is a whole number answer. I like that. It doesn't look like it is with all these square roots floating about. But yeah, we could have simplified root 8 into 2 root 2, but because you know, I'm going to do Pythagoras again, I'm going to multiply them out again. I've seen this sort of thing before, so I didn't bother simplifying the root 8, but I could have done. It would just mean you have a few more steps to unsimplify it to the end. How many sets of 3 consecutive integers are there in which the sum of the 3 integers equal their product? Right, importantly they've said integers, where the sum equals the product. So you can have -1, 0 and 1, that would be a solution. Now you can't have 0 in any others because the product would be 0, but because it wouldn't be symmetrical around 0, the sum would be positive or negative. And I think you can have 1, 2 and 3 1 plus 2 plus 3 is 6, and 1 times 2 times 3 is 6. Now I'm trying to think of any way to prove that we can't have. What about the negative? Negative 1, negative 2, negative 3 works as well, doesn't it? Because that gets you a sum of negative 6 and a product of negative 6. So I think that's the one that if you're not careful you might miss. Yeah, Rassen's just got that in chat. Well done, Rassen. I don't know whether you got it before or after me because there's a bit of a lag, but well done. So I think as soon as you have a 4, either positive or negative, your product is getting too high for the sum. If you're timesing the other 2 digits by 4, you're not going to be able to add those 2 digits to make a number high enough. So I'm pretty sure that you can't do any more. Yeah, that's what we're checking. You can't have any others with 0 in because of this symmetry. You know the product's going to be 0, so you'd need the sum to be 0 as well, which means you'd need a positive and a negative. But yeah, I believe that's the case. How many sets of 3 consecutive integers are there in which the sum of the 3 integers equals their product? That is the same question. Alright, so I've missed a question at 14, 15. No, I haven't. I've just put question 13 in twice. Well, I think it's that. Have I missed a question out then? 11, 10. I've missed question 11 out, so I'll get question 11 in a second. I'll go back to it. I need to do a bit of editing there to insert question 11. But I'll come back to do that. That's a good spot. In a number pyramid, each cell above the bottom row contains the sum of the numbers in the 2 cells immediately below it. The 3 numbers on the second row are all equal and they are all integers. Which of the statements must be true? The bottom row contains at least 1 0. Okay, which of these statements must be true? So, okay, only one of these will be true. And I'm just going to give you a tip now. I have seen this occasionally be the answer, but generally never pick that one. The one that says none of the above or none of them, or they're all lying, or you don't have enough information. Like the option to say, I don't really know what's going on. That's basically what that option means, and that's so I apologise if it is ever right, but if you're ever going to guess, don't guess that one. That's just a personal preference. So let's say that they are all x, so they will be 2x, 2x, and 4x. The 3 numbers in the second row are all equal and are all integers. Now the ones beneath x don't have to be integers. They can be whatever you want. So this could, for example, if x was 2, you could have 4 and negative 2. That would work, and whatever. But let's have a quick look at what we've put there to see what these are. The bottom row contains at least 1 0. I don't think that has to be true. It could be true, but I don't think it has to be. The third row contains at least 1 0. I don't think that's true at all. The top number is a multiple of 3. Top number is a multiple of 4. Bingo. Yeah, I've already solved it. I didn't check the answers. I just did some working out because I didn't really look what the possible answers would be, but I could have probably done that a bit quicker. Right, reflection in the line L, so there's a line on a grid L, transforms a point with coordinates 5, 3 into points with coordinates 1, negative 1. What is the equation of the line L? Alright, let's see if we can plot this then as a rough sketch. Now, you might be able to work this out algebraically. I'm just going to give us a sketch to give us an idea of what sort of line we're looking at. So, 5, 3, so 5, 3 is about here. We'll call that point A. So that's A. And then it reflects it into the coordinate 1, negative 1. Call that point B. So the line of reflection has to be something like that. So already we know the gradient is negative, which means it has to be D or E. And now we know that the y coordinate of this has to be above A. So it's got to be E, I think. I think that's going to be 4, because we know that the y coordinate of A is 3. So I think it's just going to be E. Just from our sketch. Yeah, so B and C are horizontal and vertical, and they won't give you a reflection at changes both the x and y coordinates. If you have a horizontal or vertical mirror line, it will either only change the x or only change the y if you use it as a mirror line. And then this A has a positive gradient, so the mirror line will probably go through A and B rather than between them. And then you've just got to do a bit of fiddling out which one of D and E it is. Right, so we are going to have to add I did take a picture of it, I must have just added, so browse, and we want question 11. So let's have a look at question 11, this is very professional of me, which I duplicated 13. So this is question 11, they're out of order, apologies for that if you've been following along at home. The Universal Magazine of Knowledge and Pleasure, volume 1, 1747, asks the following question. What number is that whose quarter shall be 9 more than the whole? Well, my guess is it's negative. I think you're saying that x over 4 equals x plus 9. So my guess is it's going to be negative 12. I mean, it is negative 12 because I've just substituted it in, but let's see if we can solve this algebraically. We're going to multiply through by 4, so you get x equals 4x plus 36, and we're going to subtract 36, subtract x, so we get negative 12 equals x. Yeah, I like that. So very waffly, assuming as long as you know that the whole means the whole number, not just like 1 as in one whole. Easy. Right, we're on to the other sheet now. So basically from this point onwards, if you guess and you get it wrong, or you just get it wrong, you will lose marks. You will lose 1 mark for the next 5 questions and 2 marks for the last 5. So question 16, what is, I'm going to change colour to a blue pen. I don't know why I like writing in blue, but I do. What is half of 4 to the power 2022? They always have one question, at least one, where they use the year as one of the digits. So here they've got 2022. It's our year. And you can write for, I know what the answer is already. You can write 4 to the power 2022 as 2 to the power 2 to the power 2022, which is 2 to the power 4044. And if you were to half this, you would have 1 fewer 2, so it's actually just going to be D. So if you were to half it, it's to divide by 2, i.e. have 1 fewer multiple of 2 in your digit, so it's just going to be D. Hope that makes sense. The first figure shows 4 touching circles of radius 1 centimetre in a horizontal row held together by an outer band X. The second figure shows 6 touching circles of radius 1, again held tightly together by a surrounding band Y. Which of the following statements is true? X is longer, same, okay. So we're just going to work out which is longer, and then we should be able to guess. So if the radius is 1, we know that there to there is 1. That's 2, 3, 4, 5, 6. So we know that the straight bit here is 6, and the straight bit at the bottom is 6. And then the rest of it makes a full circle, which means it's just going to be pi times diameter, which is going to be 2 pi. So the rest of it is going to be 2 pi, or pi at each side. So in total, the circumference of the shape made up, or the perimeter of the shape made up by x, is going to be 12 plus 2 pi. And my guess is that they're going to cancel out. So again, if you imagine there, that's 120 degrees. So you're going to get a full circle. Yeah, you're going to get a full circle again. You're going to get a full circle. This is a third of a circle. This is a third of a circle. This is a third of a circle. So you're going to get 2 pi again. And each side is going to be 1, 2, 3, 4. So you're going to have 4, 4, and 4. It's also going to be 12 plus 2 pi. So weirdly, they're actually the same length. Because you're cramming them in a smaller, like the best way to fit things in is a circle. So the closer you get to the circle, the more efficient you are with your area versus your perimeter. So that's not that surprising, even though you've got 2 more circles in that shape. Dick Turnip, I think we should be Turnip. Turpin, shouldn't it? Dick Turnip sold his horse Slack Bess for £56. Yeah, so weirdly they do this with quite a few shapes. They'll say, here's a triangle, and here's a triangle with some similar sides. What's the case here? And a lot of the time, because it's deceptive, they'll be the same. Or things will cancel out nicely, and it'll be the one you don't expect, which is why they're really good at giving you good wrong answers or good questions that mislead you down the wrong path. Which is why generally guessing is not going to be that profitable. Dick Turnip sold his horse Slack Bess for £56. Pretty sure you're lucky to get a horse for that price nowadays. The percentage profit he made was numerically the same as the cost in pounds of his horse. What was the cost of his horse? Alright, so I've just worked it out in my head. Let's see if I can try and justify it or do it algebraically. It's basically 36 plus 36% of 36. Is that 56? No. But 40% of 40 is 16. So if we have £40 plus 40% of 40, what the question is asking? It's asking these two numbers are the same. £40 plus 40% of 40, well this is 16, so £40 plus 16 is 56, so your answer is 40. It can't be 50, because 50 plus 50% of 50 is 75, and so on. And you're just working it out. And the problem is 45% of 45 and 48% of 48 aren't whole numbers, so they're not going to get you 56. So it was either going to be B or E, just looking at it, because you're not going to get nice numbers from any of the other ones. If you're working at 36% of 36, bleh. Without a calculator, it would take you some time and it wouldn't get you a nice answer. A sector of a circle has radius 6 and arc length 10 as shown. What is the area of the sector? Yeah. Well, the whole circle would have a circumference of pi times diameter, and this 6 is the radius. So the whole circle will have a so the circumference of the whole circle will be 12 pi. And the whole area is going to be 36 pi at pi r squared. So you're trying to find out that 10 out of 12 pi is the same as what out of 36, because the length of the arc and the area will be similar, or like it will be a similarity question, sort of. So 10 out of 12 pi is what out of 36? Well, it's going to be 30. So 10 out of 12 is the same as 30 out of 36, and the pi's will cancel out. So it's just going to be 30. Yeah. I needed a way to get pi into. I knew I was going to get pi in once, so I needed a way to get pi in twice, so the pi's would cancel. So I can't just work with circumference. I needed to bring the area in so that the other pi would cancel. Oof. My first guess was 60, I guess, but like, yeah. Either it was spelled Aaron wrong, or this is a name I've not seen before. Arun is asked to choose 5 integers so that the mode is 2 more than the median, and the mean is 2 less than the median. What is the largest possible value in the range of Arun's 5 integers? So here, never pick E. It's not going to be E. Basically, it means you don't understand the question, so, oh, well, it must be E because I can't work it out. Don't do that. Don't ever guess that. I might be wrong occasionally, but you'll do better in the long run if you never guess that, in my opinion. The mode is 2 more than the median. So if the median is 2, sorry, if the median is x, then this is x plus 2 and x plus 2, i.e. the mode. What is the largest possible value of the range of Arun's 5 integers? So what you want here is the largest possible, to get these numbers as wide as possible, and because they're all integers, you need this to be x minus 1 so that this one can be as small as possible. And then what you need is that the mean equals x minus 2, i.e. 2 less than the median. So to get the mean to be x minus 2, we need, let's call that y. We need y plus x minus 1 plus x plus 2 plus x plus 2 over 5 to equal x minus 2. And so we're just going to solve this for y in terms of x. Yeah, so for the mean to be 2 less than the median, you need one really small number. Yeah, so whatever y is, it's going to be like x minus 10 or something, or x minus, in this case, probably 12. But we'll see. So we've got 5x minus 10 equals y plus 1, 2, 3, 4, 4x plus 3. So you're going to get x minus 13 to equal y. So this one here is x minus 13. Now it doesn't matter what x is. This could be 3, 5, 11, whatever, or they could be thousands and thousands, but the range can't be bigger than whatever this is to whatever this is. That's your range, and the difference between x take 13 and x plus 2 is 15. So yeah, x minus 13. So if x was 20, you need a really small number to make the mean 18, given you've got two numbers higher than 20 as well. Right, now we're on to the point where guessing is losing 2 marks, and we've got half an hour left with 5 questions left, so we've made really good time today. The diagram shows a shaded, thank you very much. The diagram shows a shaded semicircle of diameter 4, from which a smaller semicircle has been removed. The two semicircles touch at exactly 3 points. What fraction of the larger semicircle is shaded? So, alright, so if you know your circle theorems, we know that that is a right angled triangle using circle theorems, and each of the blue lines are going to be 2 because they're the radius. So that the length of the diameter of the small circle is going to be Pythagoras. You're going to use 2, 2, and that's just going to be 2 root 2. And what fraction of the larger semicircle is shaded? Because these are similar shapes, we can say that whatever the area of the large circle is, that's going to be using a base of 4. And whatever the area of the smaller semicircle is, it's going to be using a base of 2 root 2. So you can say that the ratio of their areas is just going to be 4 over 2 root 2, I think. So see if that gets us an option. So, apologies, 2 root, hang on, what are we trying to work out? The area of, what fraction of the large semicircle is shaded? So it's going to be 4 take 2 root 2 over 4, I think. Right, I need to do this in a different way. I think I'm doing something wrong. I might be right with that, but I couldn't quickly see how to simplify that in my head. My guess is it's going to be C or D, because I don't think I've got a pi in my answer, and I think I've definitely got a root 2 in my answer. So my guess is it's probably D, because I didn't have any 3's anyway. It's hard to get, if you haven't got any 3's in the question, it's very hard to get a 3 when you're doing things like this. So my instinct is D. Oh, hang on. No, it's just a scale factor thing, isn't it? Did not know that circle theorem. It's basically if you've got a triangle where one of the lengths is the diameter, you get a right angle opposite it. Area of the white part is, alright, so we're just going to have to work out the areas, and we're going to get some pi's that will cancel out. So the small is going to be root 2 squared pi over 2, which is just going to be pi. Thanks, Rasen. And the large area is going to be 2 squared pi over 2, which is going to be 2 pi. And the difference between those areas, oh, it's just going to be a half. The area of the white one is pi, and the area of the large one is 2 pi. So my guess was wrong. Yeah, well done. You got it right. Thank you. I was looking for a quicker way to do that without actually having to work out the areas, but I guess the tricky part is working out this length here. Once you've worked out this length, then you just go back and work out actual values of the area. Yeah, that would not have been my guess if I was guessing. Well done. This is why we have chat. A rectangle with integer side length is divided into 4 small rectangles as shown. The perimeters of the largest and smallest of these small rectangles are 28 and 12. Which of the following is a possible area of the original rectangle? Alright, so perimeters of the largest and smallest of these small rectangles are 28 and 12. So we know that the perimeter of that small one is 12. So these are perimeters. So the perimeter of this one is 28, and the perimeter of this one is 12. That is really poor writing. I apologise for that. Let's try that again. So this is 28 as a perimeter, and this is 12. So to get a perimeter, I mean, am I just going to be guessing some digits here? So to get a perimeter of 12, we could have 5 and 1, which means 28 is, could have a number bigger than 5 and a number bigger than 1. 28 would be like 9 and 5, 9 and 5, 6 14s, 60, 84. Alright, so that's not a possibility. Do we know these are similar? Do we know these are similar? So 28 could be not 9 and 5. Let's say we make it more of a square. We say it's 8 and 6. So we've got 13 sevens, 91. Do they have to be similar? I don't think they do. I don't think they have to be similar. You could move that middle line down, you see. There's no restrictions where there's lines the line that's dividing that way, there's no restriction to say it has to be where it is. You can move it slightly to the left or right, which would make them not similar. I don't think that they're forced. I don't think that's forced to specifically be in a place to make them similar. So I don't think they are. I hate this. Am I just guessing? So 8 and 6, 9 and 5 doesn't work, so you can have 10 and 4. Let's try 10 and 4. But this is going to be too small. So 10 and 4 gets you 15 and 5, 75. So they're not going to work. So if it's 5 and 1, I can't get it to work without this bottom one. Could that be a square? 47, 12, 8. 12 8's are 96. So hang on. What if that was 5, 1, 7, and 7? That would work, wouldn't it? Try 4 and 2 with 8 and 6. So I think this gets us 96, doesn't it? You get 12 eighths. So I think I can get 96. Oh, no, they've got to be rectangles. Yes, they've got to be rectangles. So 7 and 7 doesn't work. So 5 and 1, we've exhausted all the possibilities of 5 and 1. So it has to be 4 and 2. The integer length is divided small as shown. The perimeters are larger than smallest of these rectangles. Yeah, so they have to be integer perimeters, sort of. So 4 and 2, and we can have 8 and 6. Does that work? So that gets us 12 8. So you can get 96. Yeah, you can get 96. So it's one I can get. Thanks ye, I don't like that. That felt a bit like trial and error. There's no guarantee that the sides of the smaller perimeters have to be integers. This could have been 3.5 and 2.5, couldn't it? So you could be trying for quite a while. 3.5 and 2.5, and then you could have 8.5 and 6 and 5.5. Now that gets you the same answer of 96. So there's lots of ways to get 96, I guess. So I guess the fact you can only ever get 96 as one of the options might make that fine. I don't like that question. There might be a better way of doing it, but I haven't got the answers in front of me, so I can't check. But I don't like questions where it's trial and error. Apologies. Two squares are drawn inside a regular hexagon with side length 2 as shown. What is the area of the overlap of the two squares? So a regular hexagon means all the angles and sides are the same, so all the sides are going to be 2, so that's 2, 2, 2, 2, 2, 2, and the angles are 120, so you've got a right angle and 30 degrees. So what is the area of the overlap of the two squares? So what we're trying to do is work out the length of this line here. If we can work out the length of that line, so I'm just going to make that a bit bigger. If we can work out the length of that line, we can work out the height of the shaded area. Because the length of this line here, let's call it y. I don't know why y, but and so that's 2 to 30. Um, 60. We can use trigonometry just on this side here. So we can say that y equals 2 times cos 30. Sorry, half of y equals 2 times cos 30. So y is 4 times cos 30. And cos 30 is root 3 over 2, so y equals 4 lots of root 3 over 2, which is going to be 2 root 3. So the height of that line is 2 root 3, so the height of the shaded area is going to be 4 minus 2 root 3 multiplied by 2. So the area is the height of the little blue bit here that I'm highlighting there, the height of that. So the area and the height of that is going to be 4, which is the height of 2 of the squares together. Take off the 2 root 3, that's the overlap. So 4 take 2 root 3 multiplied by the width of the shaded area, which is 2. So the area is 8 minus 4 root 3, which is that option there. That's that. Sweet, that was quite nice actually, compared to question 22. I liked that one. Pete's pies all cost an integer number of pounds. A cherry pie costs the same as 2 apple pies. A blueberry pie costs the same as 2 damson pies. A cherry pie and 2 damson pies cost the same as an apple pie and 2 blueberry pies. Paul buys 1 of each type of pie. What of the following could be the amount he spends? Alright, so I'm just going to call them X. No, I'm not. They've been very nice. I'm going to call them C, B, A, and D. So cherry pie is C, A, B, D. So the information we have, we know that a cherry pie is 2 apple pies. We know that a blueberry pie is 2 damson pies. We know a cherry pie and 2 damson pies is the same as an apple pie plus 2 blueberry pies. Paul buys 1 of each type of pie. Which of the following could be the amount he spends? Hum. 2x is 2d. So you could say 2a plus 2d is a plus 4d. And I've substituted 2b for 4d and 2a for c, which gives you that a equals 2d. So a and b are the same. Now someone in chat has chucked an answer at me, but I don't know why. So I'm going to keep going to see if I can explain my thoughts. So A is 2D, but B is 2D. So we've got another fact that A equals B. And now rather than substituting C and B out, I wonder if you could substitute so if we go this way, if we substitute the other 2 out, if we substitute oh, hang on, no, there we go. We've got it, I think. Yeah, we just need to write them all in terms of A, don't we? So we've got A equals B, we've got 2A equals C, we've got A equals 2D, so we can write them all in terms of A. So 1A plus another A, because A is B, plus a half A plus 2A. No, other way around. If 2A equals C, yeah, plus 2A. I've got those the wrong way around, but the same principle. C should be 2A and D should be a half A, but you get the idea. So in total, this is 9 halves of A. So the multiple number of pounds must be a multiple of 4.5, and the only multiple of 4.5 here is 18. Yeah. Alright. That was I made that harder than it was. You just need to write them all in terms of one letter, and for some reason my mind blanked. Once I got to this point, I didn't use the fact that A is 2D. I just used that fact to work out that A equals B. Alright, last question. We have 10 minutes to solve it. Alvita is planning a garden patio to be made from identical square paving stones laid out in a rectangle measuring X stones by Y stones. She finds when she adds a border of width 1 stone around the patio, the area of the border is equal to the original area of the patio. How many possible values for X are there? So we've got, let's just say for whatever reason that this is X and this is Y. The area of this will be XY, and the border around it will be X plus Y plus an X plus a Y plus 4. Plus, because the area of these are going to be 1 because they're 1 by 1 stones. Apologies, they're not going to be 1, but they're going to be, let's say that the area of a stone is 1. Just to make it easier, it doesn't actually matter. It doesn't actually say, they're just identical they're identical square paving stones, and so if it isn't 1, it is still an enlargement of 1 because they're square. So we know that the area of the patio equals the area of the outside bits is 2x plus 2y plus 4. So how many values of x are there? Well, we could rearrange it in terms of x and see whether we get a quadratic in y. And if we get a quadratic in y, then there's probably going to be 2 solutions. My guess is it's 2 solutions. There will be one solution works when x is the largest, and then the same solution when you swap x and the values of x and y. So my guess is 2 solutions. So x take 2x. So we'll try that again. X, y, my guess is going to be 2. I'm going to guess 2 if nothing happens when I do this. Equals 2y plus 4. You're going to get x lots of y minus 2 equals 2y plus 4. And then you've got x is 2y minus 2 over y plus 4 over y minus 2. I think I'm just going to guess 2. But my guess is, because it's the last question, I don't think it's going to be as easy as 2. It could be 4. Well, you know they've got to be integers, so how many ways are there to make this an integer? That might be the case. If 2y plus 4 over y minus 2 isn't an integer. So how about we try to divide them and get no remainder? So if we do 2y plus 4, how many y's minus 2 is going to that? Y into 2y goes twice, take away 2y minus 4. Take 8. I want to guess 2, but I haven't got. I think it's going to be. Could just be 1. Actually, wait a sec. Uh, 2y plus 4. I'm doing something wrong here. I've got 5 minutes to get an answer. If nothing happens, I'm pretty sure that it's B or C, but I don't know. Chat, I will take solutions if you've got one. I think I'm on the right track as well, and I'm just trying to think about how many solutions this could have. But they've got to be integer solutions. In theory, there's an infinite number of solutions that this can have. But how many integer solutions have they got to be, where y is an integer and x is an integer? So let's say that yeah, thank you very much. Yeah, I can continue from where I left off here. So I'm going to go from this bit here, and I'm going to go on another slide actually, just to get some prospects. So because 2y minus 2 is going to 2y plus 4 with 8 remainder, we can say that x is 2 plus 8 over y minus 2. The 8's the remainder. There we go. And what we need to do is make this an integer. So how many factors of 8 are there? There are 4 factors of 8. So you could have so how many ways can we make x an integer? Well, this would have to be an integer. How do we make this an integer? We've got to find a number that goes into 8 without a remainder. So we could have 8 divided by 8 gives us y is 10. 8 divided by 4 gets us y is 6. 8 divided by 2 gets us y is 4. And 8 divided by 1, which gets us y is 3. So because there are 4 y values, they will get you the 4 x values. And my guess is that when y is 10, x is 3. Yes, that's right. And so when y is 10, x is 3. You're just going to get the converse. When y is 6, x is 4. When y is 4, x is 6. And when y is 3, x is 10. You're just going to get the converse of what we've just done there. So I believe there are 4 solutions. Yeah. So I believe there are 4 solutions. My guess was 2. Our guess was wrong. That's why it's the last question of the paper. Thanks, LaPresse, for telling me I was on the right track. So I got stuck at this bit and thought I'd done something stupid. But that's what I tried to do, and then this is much easier to look at than what we were looking at down here. This is bleh. Bleh. So we're going to go and mark it now. So we're going to go back, and if you've done this yourself, get out your marking pen. And the way we're going to mark it is, if myself and a guy called Tim Lister, who teaches maths, have got the same answer, then we're going to say it's right. And if it's not, we're going to have a quick look. And if I'm not sure I'm right, I'm going to leave it in doubt. So question 1, I put B, Tim's put B, correct. Question 2, I put A, Tim put D. I think I'm right there. I'm going to go that I got that right. There's 200 grams, 100 plus 50 plus 50 is 200, and 2.5 lots of that is 500. Yeah, I'm pretty sure I'm right there. I think Tim's just done a boo-boo. Yeah, right. 2.5 times each amount, so 2.5 of hundreds is 250, 2.5 50s is 125, so I'm pretty sure I'm right there. Do we agree, chat? Well, chat's going to let me know if they agree. I think I'm right. It's the second question. I think Tim's just had a bit of a brain fart. I put B, Tim put B. I put D, Tim put D. Chat agrees with me. Thank you, chat. Question 5, I put C, Tim put C. Question 6, I put D, Tim put D. Question 7, I put C, Tim put E. Now I'm pretty sure if you put 102 in, divide by 3 gets you 34, take 10 gets you 24, divide by 3 gets you... What have I done something wrong? Oh, I've done something wrong. I think I've got this one wrong. 102, 34, 24, 8. Yeah, okay, I've done something wrong here. So 1, 11, 33, 43, 3 43s, 129. Yeah, I got that wrong. So I've got a mark wrong there. I just did a brain fart. I did 3 43s as 102, but it's 3 34s as 102. That's fine. Everyone's fallible. That's why we check it. Question 8 is A. Question 9, I put E, Tim put E. Question 10, I put C, Tim put C. Question 11, I put A, Tim put E. Now I'm pretty sure I'm right here. Oh no, question 11 is the one we missed. Sorry, question 11 was, we did a boo-boo, didn't we? So question 11, yeah, we both got E. Question 12, we both got A. Question 13, we both got C. Question 14, we both got D. Question 15, we both got E. So for the easy questions, or at least the ones you don't get penalised for, I got 14 out of 15, as did Tim. We got 2 different ones wrong. And we're on to question 16. We both got D for 16. Change to a green pen, please. Thank you. Question 17, we both got C. Question 18, we both got B. Question 19, we both got A. Question 20, we both got D. Now onto the hard ones. Question 21, we both got B. Question 22, we both got D. Did not like that question. There might be an elegant way of doing it. So if you're doing this at a later date and you can check the mark scheme, just check the mark scheme for what they suggest to do for that question, because mine was just trial and error. I didn't like it. Question 23, both got E. Question 24, we both got B. And question 25, we both got C. So, this is my marking plate. So our score, we got 14 easy questions for 70. We got all 10 hard questions for 60, which gives us a score of 130 out of 135. So I imagine some people will do better than that. But if you haven't had a go at this in real life and you want to post the score you get when you get it, please just comment on the video below. I'm going to continue to do the maths papers as they come out. If you are watching in the future, I will do the papers. I can't do them the week they're out. I don't think that's fair to anyone still sitting the papers. And given I'm no longer working in school, I can't get access to them quickly enough. So if you're pestering me for papers in the comment section the day after you've sat it, I won't be able to do that. However, I will endeavour to get them out within a week of the paper you sit. So please bear with me in future. But otherwise, I've been Steve, and thanks for watching. Happy maths.